Welcome to the third LAMP Lite Byte. A lot has happened for the Learning Actively Mentorship Program since the last Lite Byte. We have had some excitement with regards to the planning and scheduling of the Summer Institute for faculty and graduate students. We're still in the throes of a lot of planning for that, but we're looking towards the week of June 6th or 5th through the 11th-ish. So that'll be a fun thing to look forward to. Additionally, we're looking at more collaboration with the College of Education, and we're evolving our LAMP Scholars Program. So today I want to take your attention back to our active learning spectrum, and I would like to zoom in on one of my favorite active learning techniques. In fact, this is a technique that I cover here in the second one, because it is one that will support your institution of many others on the spectrum. This is the flipped classroom. So the flipped classroom literally means turning your class on its head. And I mean that quite figuratively, not literally, because what we're talking about is taking what would normally be a very dry and mundane and very teacher-centered lecture and taking the content from that lecture outside of the classroom. That is, you would be producing short videos that would encompass a lot of that content knowledge, that content delivery in an outside location. And there's a technical definition that we might look at for this flipping notion. And I love this review that is provided through Pearson and others, a review of flipped learning. If you want to check this out, it's a bit lengthy, but I suggest it. So provided by the Flipped Learning Network, and one that really does a nice job of reviewing flipping. But I want to draw your attention to just one of the quotes that comes from that. When we think about flipping, basically it's teachers shifting direct learning out of the large group learning space and moving it into students' individual learning space. So I very intentionally chose this picture of one of my students, Monty, on his cell phone. He's reviewing some of the virtual edge content that is content that I've pulled out of the lab and that I provide in many forums online, interactive and passive. And this content is outside of the lab and can be viewed outside of the lab prior to coming to lab. So it shifts this into maybe a video format or an interactive format that could be accessed online. Some instructors, I have never done this, but some instructors even use videos like TED Ed and Khan Academy videos that they can utilize to allow their students to engage in that content outside of the classroom. Now, the reason that I think flipping is so absolutely magnificent is that it does put the content into the student's space. Nothing can be more personal than our cell phones. I mean, all of us, I know exactly where mine is, right here, and can grab it at any moment. And it suddenly takes what is teacher-owned content and makes it student-owned content. Suddenly, students are capable, just as you are right now, of pausing me. Rachel, I don't want to hear any more pause. They're capable of rewinding me. Wait, what did she say? Because she was going really quickly and I didn't get all of that. You can go backwards, you can go forward, you can skip around, you can review the content. And this empowers students. So this quote also in the 2013 review of Flipped Learning, due to the emphasis on students becoming agents of their own learning rather than the object of instruction, the flipped learning model enables educators to make the shift from teacher-driven instruction to student-centered learning. When we think about teacher-driven or teacher-centered instruction, it means that you completely own that content and you're only giving it out in those very few moments within the lecture hall. And if a student somehow doesn't get something, well, that's their fault, right? It's very power heavy on your side, right? If you're an instructor that gives only that one moment of brilliance in the classroom, students can't re-tap into it. And so this is a way to empower students, but it's not only a way to empower students, students. It is also a magnificent way to allow you to change what's going on in your actual face-to-face time into active exercises instead of just lecture delivery. So once the content has been pulled out of the lab, that enables a great deal of flexibility within the classroom to engage in active learning strategies, maybe to review case studies, maybe to do peer assessment, perhaps to create learning objects. For example, my students make a huge, beautiful metabolism poster that enables them to actually be creating content in the flipped lecture periods. So in order to flip successfully, there are a couple of important things. First off, you have to make sure that the material, the content that you give them to be reviewed outside of class is flexible, that students can choose when and where they watch it. I like to encourage my biochem students to take their water vodcasts and watch them next to a river or a stream. I like to encourage them to be in a context that makes them feel comfortable and relaxed when they review the lecture. It allows them to rewind, to fast forward, and to really engage in their own time. It gives up power for us. This is a hard one, right? Because let's face it, I kind of enjoy having the power in the classroom. And so it's a little bit hard for me to think about giving up that power and to stop being the center of attention. I mean, heck, every classroom is designed so that we're the center of attention. That's what's going to be new in the new classrooms, right? We won't be the center of attention anymore. So it means giving up being the center of attention. It also means embracing chaos, because once you take the content out of the lecture, then you bring students in, having already reviewed that, ready to ask more advanced questions, ready to hit you in areas you don't even expect they're going to ask questions. But it also means that you, in that chaos of allowing them to inquire, allowing them to discover, allowing them to maybe make their own materials, in that you really need to be purposeful with your student-centered pedagogy. So you do have to plan something for that time, and that makes it hard, because that means there's a little bit of extra planning time. Not only are you delivering the content in your vodcast, but you're also having to come up with some sort of case study or some sort of meaningful share, pair, square activity that you're doing in the period that would normally be the lecture. So this also means that we have to do the hard stuff in class, and that's hard, because it used to be that if we could just send students home to do their homework, then their struggle and their hitting their heads against the brick wall was localized to their space. We didn't have to deal with any of that hard stuff. But now we have to see their struggle, and in a flipped classroom, when they're working on a hard problem, maybe that's what you do, is a problem-based activity when you're in class. And so maybe they're working to solve a very hard problem, and we have to just figure out how we're going to help that struggle. So it means that we're having to constantly provide meaningful and individual feedback. We're actually getting in the fray, and sometimes that is very uncomfortable. So, but it's rewarding, right? And so it takes away from that. No longer in a flipped classroom are we teacher-centered, right? Because we're no longer focusing on the decontextualized acquisition of knowledge. Now we're seeing the contextual application of knowledge and the struggle that comes with that, right? The greatest moments of struggle precede the greatest moments of learning. What are some benefits of flipping? Well, students do become empowered. They gain control of the material. They can decide when and where. It does increase our ability to engage in active learning, and we've talked about that already. When this 2013 article that I showed you earlier, the Flipped Learning Review, was written, there wasn't a lot of good information, good replicable studies that had been done to show that this actually increased academic performance. More of those studies are needed, but I just read one that was literally published not long ago, 2016, that looked at increased academic performance in large chemistry lectures that had decided to flip. So these were lecture halls of 250 to 500 students. And they changed their strategy doing the flipping and the more active style, and this did increase academic performance. It's interesting to consider the fact that if you're a English second language learner, then when you are in a lecture hall, and I mean, let's face it, when I talk really quickly and I get jazzed about translation and all of the ribosomal action, and I'm speaking very rapidly, and if you're not English as a first language, then it's very difficult. You can't pause me, you can't slow me down. But if you can move the lower levels of Bloom taxonomy outside of the classroom, these are the remembering and regurgitative type elements of knowledge. That is the acquisition of the language of science. If you can move those things outside of the classroom, then English language learners can pause the vodcast. They can look up a word, they can come back to it, and it enables them to not have so much struggle just in understanding the language. They can go at their own pace. Now, this last one I want to talk about a bit, reduced cognitive load. Sweller's 1988 cognitive load theory basically says that there's a limited amount of information that can be cognitively processed, especially if we present via a single channel. So if we just got text or we've just got audio, then it's limited. We can only process so much. Of course, we can only process so much. One thing that we do know is that you can process more if generally it's accepted that you can process more if there's a dual channel modality, like if you've got both audio and video coming at you, just like you've got right now when I'm chatting with you. That's actually more effective than, say, a textbook, right? The visual word and the picture coming at you. Now, there's a little bit of disagreement on that because it might have to do with how complex the material is. And so I want to talk to you briefly about a very recent study that looked at nursing students who obviously have to have math skills. This is a constant struggle for me in my medical microbiology labs, where nurses often have not mastered certain math skills. So this was the case in this study as well. And so what they did is they compared a traditional versus flipped instruction, but they did so at different levels of complexity because they wanted to see whether flipped instruction was equally effective at all levels of complexity. And what they did find is that it was most effective to flip at moderate levels of complexity. That is with regards to the accuracy of their problem-solving skills, algebra problem-solving skills, particularly at moderate complexity of questions, they increased in accuracy. We also see a decreased mental effort, particularly at high complexity questions. This is huge because think about how we can sort of bring down the stress associated with high mental effort so that then this can enable greater accuracy and greater success for students. So this was a super interesting yet very complex article. Let me know if you'd like a copy, but I thought this was so neat because it answers the call for more studies that really look at cognition and accuracy as an impact of flipped classrooms. Now, I have to admit, I'm not going to admit how long ago I started flipping because it would give you some clue as to my age, and I don't want to do that. So I will just say that way back in 2008, we started publishing on flipping in microbiology and biochemistry. And really, students universally like flexibility of vodcast lectures. In fact, that's the thing they love about it. And we saw some similar results to what was seen in the review of flipped learning. This image comes from the review of flipped learning. 80% of students agree that they really like the ability to work at their own pace. Our numbers were very similar to that. They like having greater access to the course materials. They have the choice. There's an increasingly democratic classroom. And this is cool. So they feel as though they're more likely to engage in collaborative decision making, more likely to engage in critical thinking and problem solving, right? This is great. The teacher is more likely to account for their interests, strengths, and weaknesses. So it takes this and makes it very much a student-owned environment. So here's what's going on right now in the microbiology lab, and let me tell you, this is chaos. We decided to partially flip last semester. That is all introductory material that would normally be delivered as a short 20-minute lecture at the beginning of the lab is now delivered outside of the lab. And I am doing most of those vodcasts to deliver that. However, some of my TAs are trying their hand at it. It's not easy and they're loving it, but it's hard work. So we did last semester kind of a preliminary quasi-experimental study where we looked at differences between flipped versus traditional. And what we actually found is that in our study, there was no significant difference, at least not with the statistics that I did. So basically, there wasn't a big difference between flipped and not flipped. But here's one confounding issue, and this is worth note. What was happening was that students who were not in the flipped lab sections were actually finding the vodcasts and they were watching them and then still engaging in the traditional introductory lecture. And so, of course, when asked, they all said, yeah, bring them on. We want flipped labs. They wanted the vodcast. They wanted to be able to actually both watch them ahead of time and then have them again in lab. So who says students don't want more education, right? So we really did find that most students in general microbiology did report that they would like to have all 24 laboratory introductory lectures vodcasted, and this is what we're doing this semester. Come hell or high water, it's a lot of work, but we're getting it done. So why do I love flipping? Well, I love giving away ownership of the content. I love saying, I don't own this. This is not my knowledge. It's not mine. It's not mine to close the gates on your access to this knowledge, to limit it to just the delivery that I give in one lecture period. I like giving away that ownership. I like slowing down and drawing more. And I know it's hard to believe I actually do that, but I'm more tended to do that in a vodcast. I can get my pen and I can draw. And I'm going to show you some clips here in a minute. I can take my students anywhere. This is my favorite part. When we're talking about water, I can take them to the Uncompahgre River watershed. When we're talking, contextually, for example, the other day I was talking about tests to look for diagnosing and affirming the identity of Streptococcus agalactiae, and I could take them onto the ranch where I said, hey, this is one cause of mastitis in cattle, right? So I can take them anywhere, and that's what I love about flipping. So there are a lot of resources on flipping. Let me tell you, I actually got a little overwhelmed and spent way too much time with this lamplight Byte, so I hope someone watches it. But if not, at least it was a good exercise. So in any case, let me know if you're interested in any of these references, and I'm going to take a moment. Hey, stay with me, because I want to show you some of the places I've taken the students, some of the ways that I've hundreds and hundreds and hundreds and hundreds of hours of vodcasted lectures. So sweet.
Is absolutely the universal solvent of life, and it comprises 60 to 90% by mass of all life. So we recognize the role of water as in its role as salivating ions and polar molecules, but additionally we recognize water as being at the heart of the biology of the area. So enzymes act in response to water. Macromolecules fold in response to water. So proteins, for example, will collapse in a way that we call the hydrophobic collapse, where the center of the molecule gets away from the water by folding into its native structure. So all of life responds to water. Life is very much a water-based phenomenon. So what a better place to think about water than in this beautiful Uncompahgre river area. This is actually the Dominguez River, and I've built my own little water molecule. There's not much you can't do in nature with some pine cones and some sticks. Our large pine cone is the central oxygen atom bound covalently to 2 hydrogen atoms, and this creates a molecule that is a bent molecule. It has bent geometry, and you can see that here. Here we are back in the Uncompahgre Water Rivershed, only this time we're at 10,000 feet up on the mesa rather than being down in the bottom of a canyon. We're pondering why it is that ice floats.
So you can see behind me we've got some sweet ice. It's beginning to melt as the day gets warmer. And you're thinking, wow, why is it that ice floats to the top of the water? Ice is actually phenomenal because the hydrogen bonds in ice are perfectly aligned. So rather than in liquid water where they're ephemeral and not quite aligned, in ice there's a perfect alignment of the hydrogen bonds, and that perfect alignment allows for the hexagonal lattice to form. And the hexagonal lattice has greater space in it than in the fleeting hydrogen bonds of water. So water is actually more dense than ice. Water is unlike any other molecule in that way. Typically at solids, they become more dense, but water, because of the space that's allowed by that hexagonal lattice, becomes less dense. Therefore, the life-giving feature of water that allows it to float to the top. You can say pretty certainly that you do have Streptococcus agalactiae. So how does all of this relate to being here on pasture with the cattle? Well, it does a lot, because there is a condition in cattle that many of you have heard of called mastitis, which is an inflammatory condition caused by bacterial infection of the mammary glands. And this is problematic, particularly in dairy cows. Of course, any cow, right, it's gonna be a problem for, but it's often noted as something that causes problems for dairy cattle farmers. Because it's low molecular weight, and that the blue dye, because it binds to the high molecular weight protein, will be retained in the dialysis tubing. So we're going to do this cooking show style, and I'll be back with you in just a minute. Okay, so to begin with, I'm adding the cationic or positively charged dye called methylene blue to the protein, and we're hoping that the negatively charged protein will bind to this positively charged dye. So in the falcon tube, you can see there's BSA, bovine serum albumin, the negatively charged protein. I'm adding in the positively charged dye, and I'm going to mix this quite a bit, and I'm going to allow it to sit for a while that positively charged dye binds to the surface of the anionic protein. Now, after allowing that to sit for about 10 minutes, I'm adding the negatively charged Congo red dye. I'm hoping that this negatively charged dye will be repelled by the negatively charged surface of the protein. Now, it's important to note that I did add more of the negatively charged dye than did I the positively charged dye. This is important because in case the two dyes interact with one another just a little bit, there should still be an overwhelming amount of negatively charged dye interacting with the negative protein, and hopefully excluding that negatively charged dye from the dialysis tubing.